up right now. Good afternoon. My name is Kristen Vandenhavel, and I'm Director of Impact and Engagement at the Water Tower. We're so excited for you to join us today for this virtual Lunch and Learn. And today we're really focused on sustainable water in the built environment. We have two very knowledgeable experts on the phone today with us. So let's go ahead and get started. So just to give you a little bit of background information on why this webinar came about. When we talk about large commercial buildings in the United States, they use on average 7.9 million gallons of water per year. And that goes to purposes for cooling, heating, dishwashing, irrigation, sanitary systems, costing them upwards of $14 billion. So corporate sustainability is a big focus to counteract that. It creates long-term value for companies by intentional, sustainable water management for the built environment. To support this mission, and our mission at the Water Tower of providing innovative solutions for the water industry, we work closely with forward-thinking companies focusing on strategies for building scale technologies to help facilities meet those corporate responsibility goals. We're excited to highlight two of those today. So we have two expert speakers on the line. This webinar is being recorded. After each speaker, we will have about 5 minutes for Q&A. And if you would like to submit a question, please type it into the chat box and we'll get through as many as we can in the Q&A after each presentation. So now I'd like to introduce our speakers. Our first speaker is Adam Koch. Adam has worked in healthcare for almost 20 years and is currently a network director of plant engineering for Kettering Health main campus, Goyne Green and Hamilton hospitals, with multiple outbuildings under them. Adam has a BS in electronic engineering from DeVry University, an MBA from Indiana Wesleyan, and CHMFM through AHA, a lot of acronyms there. He is involved in the State of Ohio Environmental Leadership Council for Sustainability and serves as a board member with the Ohio Society for Healthcare Facilities Management. And our second speaker is Chad Wilbanks. Chad has 20 years of experience in the water industry. He previously served as wastewater manager of the Wayne Hill Water Resources Center, superintendent of the Crooked Creek Water Resources Facility, and pump station section manager for Gwinnett County Department of Water Resources. Prior to joining the Water Tower, he also served as a subject matter expert for the training department, where he developed specific training programs to help DWR's over 600 operations and maintenance staff members not only pass their certifications, but hone their skills to maximize their advancement opportunities. We're very excited to get going with the presentation, so I'm going to hand it over to you, Adam, to get us started today.
Okay, well, thank you, Kristen. So again, my name is Adam Koch. I am Director of Facilities with Kettering Health. I have about 4 of our major sites, and another colleague has the other 4. So happy to be here and share our story that started back in about 2018. So go to the next slide, please. So it all kind of started out with what is water harvesting? And this is the presentation that we actually gave to our C-suite. But essentially, water harvesting is the process of capturing water from any source. So rainwater, groundwater, condensate, gray water. And we had a conversation in 2018 with one of our vendors, ChemSearchFE, and they came to us and said, hey, we have this idea that we would like to run by you and see if there's any opportunities. So is there opportunities to pull condensate from the air handlers and get it to processing areas, or opportunities to pull gray water or roof water? And it being in a 60-year-old building, we just really didn't have that opportunity to do it. But then the question came up of, well, do we have groundwater anywhere? And just so happened, we do. Actually, we have a 200,000 square foot garage that's underground in the front of our building that has a collection cistern that does have water. So back in 2018, we also sat down with our local water company, came to us because they were having pricing increases, and they knew that we were a big water user. So they came to us and said, hey, in 2018, you're going to have a 33% increase in water cost. And then every year after that, through the year 2025, it's going to be 6% increase. And that allows them to go through and completely revamp the water system. So it couldn't have been better timing for this conversation. It's like, okay, now how are we going to work to save on water? So, but next slide, please. So just a little bit of background on us. Trying to find water, we didn't have any options for any drilling of wells for our cooling towers. We actually have a sister hospital that does have their own wells, so they don't have any towers. But our building is 1.2 million square feet. We have 38 tons of cooling capacity with 4 chillers, 9 towers total, system volume of 53,000 gallons. And at the time, we were using about 16 to 17 million gallons a year just on our cooling system, not including all the drinking water. But that garage cistern is 15,000 gallons. And when we built the garage in '83, there was pumps that were designed to go out to the storm. So since 1983, we've been pumping water essentially away from our building. And the next slide, please. So we talked about the increase from the county, but after we had this conversation, we kind of looked at that cistern and said, yeah, we could possibly do something like this. We were going back and forth on how the system would be designed. But in 2019, in February, a contractor was working on a bridge and accidentally broke a 36-inch pipe under the Great Miami River. They didn't know that they broke it, but it released about 150 million gallons of water within, I think, a 24-hour period. Well, part of the city went down, had no water pressure. Luckily, there's a water tower right up the road from us. We continue to maintain pressure, but it's like, okay, there again, reemphasizing this, the issue of what happens if we lose water. So we kept having these conversations with ChemSearch. And then Memorial Day of that same year came, and the F4 tornado that came through knocked out both of the county's pumping stations. So for a few days, there was low pressure. They were able to reroute some water back to us, so we never lost pressure. But again, it really emphasized we need to do something. So, but if we did lose pressure, all of our building cooling goes down, our radiology equipment goes down, and our data center for our system is on this campus. So essentially all of our Epic and communications pretty much go down as well. So, and then talking with Rahul from ChemSearch, all the concerns in the West about, the drought conditions of like Lake Mead and other lakes of, consistently not having rainwater, and what would happen if we had that issue here and we weren't able to pump from the county. So, but anyways, we tied all this information together. We actually took this presentation to our safety committee, to our emergency operations committee for the approval of concept, and then we discussed with the CFO. So next slide, please. So some financial information, when we did this, roughly about $415,000 to install this type of system. Ongoing costs about $15,000 a year with general maintenance and chemicals and stuff that we need to make sure that we're not clogging those membranes on the RO portion. And then we estimated about $125,000 in savings in 2022. So again, we started the conversation in 2018. In 2019, we had some issues. I think everybody probably wants to forget what happened in 2020. And by the time that we finally got approval, we were in the 2021 era, and then we actually started in 2022. So, but we estimated about 125. And again, we were a 6% increase every year through 2025. Some of those calculations we had talked about, we're currently using about 5.5 cycles within our towers, and we figured we could get somewhere up in the 8 range of using that water before it had to turn over. So how many times? And we estimated about a 3-year ROI. So it was a little bit higher than the CFO wanted, but we stressed the emergency operations portion of this more than anything, and some of those issues. So Next slide. So some of the questions that we did get. So how are we estimating the amount of water that we would save? So we actually monitor our cooling towers and our makeup meters through an Advantage controller. We get digital readings and reports, and we can go back a year, we can go back 2 years, I believe, and be able to pull that data. So we're able to estimate off of that data. Cycles of concentration, again, the amount of time water can be used before we had to reintroduce fresh water into the cooling towers because of solids. There was a question about, is the garage water sufficient to run the system? It is the quality consistent? So the cistern itself, when we originally looked at this, we did not have rain for about 4 weeks. And when we took readings, we were getting 5 gallons a minute going into that cistern. And what we didn't realize at the time was that was just one pipe we were taking from where we could actually see from above the cistern. There's actually 8 pipes inside that cistern. So we don't know how much other rainwater was going in or other water, but we had quite a bit in there. So the water quality was good, being groundwater, but it had really high conductivity. And then why does the project matter? So obviously utility savings, natural resource conservation, and emergency preparedness was the big 3 for us. So next slide, please. Kind of give you guys an idea. That's a very basic layout, but starting from left to right, the cistern on the left with the transfer pump, essentially we're moving it from that point into the RO skid. There's an anti-scalant chemical that goes in to make sure that those membranes in that RO system don't get jammed up. We then take the RO over to a holding tank and run it through a UV filter so it doesn't build bacteria. And then we have the booster skid that essentially pumps it to our cooling towers. So very basic, very crude. We're like, oh yeah, this will be easy. So the next slide, please. So once we got into it, we kind of made a lot of changes. So ChemSearch came out and worked with us and said, hey, what if we introduce a little bit of raw water? What if we took this reading at this point? What if we, changed this design? So, being a newer technology, it was actually, we were the first healthcare organization, but we were running just behind the first business to install it. I'll say Bank of America did one out in California right before we got finished with ours. So we weren't the first in both the categories, but we were first healthcare. But anyways, so shows you kind of, we learned throughout the whole process because it was a brand new thought on how to get water for our towers. So next slide, please. The picture on the left is a blueprint of the outside. So if you look in the bottom right side of the blueprint, you'll see a darker black line going up, going around, going down. So we actually pushed a line probably about 500 feet from the cistern around the building, got it into a mechanical room, ran about another 150 feet to where the RO system actually sits. So about 650 feet we had to get around the building to be able to grab this water and process it. And then on the right, the 2 big pumps in the back, those are new storm pumps. And then the small pump kind of in the front right side, that is the RO pump. So the way we set it up was the RO pump takes priority, but if that cistern level continues to get higher, those storm pumps would then pump out additional water. So that way we're not flooding. It's actually in the basement of the garage. So next slide, please. So here's a picture of it. So on the left side, the transfer pumps. And one thing we learned with the transfer pumps is we really need to make sure those are on VFDs, because if some of you know, pumps come on, it will slam that water as hard as it can. So we had to build that water up and slow it back down when we were shutting it off. But you can kind of see there's an anti-scalant tank in the middle, the RO package on the right side. And then the holding tank in the right picture, that 1,000-gallon holding tank. So then next slide. Just some other pictures, but essentially the water comes down on the right side of the system, goes through that pre-filter, goes through a booster pump, gets pushed through the membranes, and then goes back to that holding tank. So next slide. So here was some interesting data. So again, as we have been monitoring our data over the years, and this data is outdated, obviously, but we did a period of April 20th to May 16th because we technically turned it on April 20th, 2022. But in 2018, our city supplied makeup gallons was almost 1.5 million. 2019, 1 million. 2020, almost 700,000. 21, 900,000. Well, in 22, when we turned it on, we used 1.1 million gallons, but the city supplied was only 120,000, where the harvest system supplied almost 1 million. So big difference there. But the graphs kind of show you that day to day how much was used in 21, and the lower one was how much city makeup was used in 22 during that period. So we reduced, 89% of that city supplied makeup water within that time period. Next slide, please. Some fun sustainability facts. So average household size is about 2.5 people per house, and the average person uses about 100 gallons a day. So we extrapolated that to be about 91,000 gallons a year per house. So we were estimating 12 to 13 million gallons of water that we could potentially save, or 131 to 142 homes worth of water. So imagine building 142 homes with not actually having to do any infrastructure upgrades or any additional pumping stations, those type of things. So next slide. So opportunities learned. So clean the existing tank prior to having the system go live. We've had minor issues with dirt and other things that get introduced into that cistern, since that cistern had been there for 40 years at that time, sludge in the bottom. So we ended up cleaning that tank out afterwards, making sure that if pumps are turning on and off, if they are on VFDs, to avoid breaking anything. Getting your control vendor engaged early. I think probably one of our biggest hurdles was, when does this turn on? When does it turn off? When does the city makeup turn on? When does it turn off? So making sure that we're thinking through that ladder logic, I'll call it, of how we want to actually use the most amount of harvesting that we possibly can. And then thinking about making sure that you're capturing and monitoring what we're doing. So capturing water coming into the system, capturing water going out of the system as far as meters and controllers. That way we can get that good data to prove what we're actually doing. Considering the size of the system and the path and the location. So, we bought this system that can process 50,000 gallons a day. We knew what we were getting into, and then we forgot to look at the height of the overall system, and we had to take part of it apart just to get it in the building. So knowing your path of getting equipment into the building and making sure that you can get things through the door. That 1,000-gallon tank was a very interesting challenge to get into the building, but we ended up getting it in. So, but yeah, discussing sequence of operation early and often. Again, knowing when you have water, knowing when you don't have water, when the system's requiring it. So lots of opportunities. Next slide, please. And that's it. We've had this system now online for 2 years. We've made other improvements to our towers and to our chillers. We've actually reduced a lot of water. So the first year we did save about 125. This year, I told the CFO we saved 143 in the calendar year of 23. We are estimating somewhere around $148,000 to $152,000 in water saving water and sewer savings for 2024 at this point. So it's been an interesting project and felt like it took forever to implement, but it's been good, and it's been one of those things I love to talk about. So happy to answer any questions.
Thanks very much, Adam, for that excellent presentation. We're going to go ahead and answer some questions. Be sure to type in your questions in the chat if you have them for Adam. We'll go ahead and get started. First one is, how do you deal with any oil and grease picked up by rainwater as it comes in?
So we did do water analysis in the beginning and found very low oils in there, but that pre-filter will pick up quite a bit of it, but the RO media will pick up the remainder of it. We were worried about being a cistern for a garage. If there was an oil spill in the garage, what would happen? Luckily, the way the garage was built was all the drains go to oil separators before it goes anywhere else. So the hydrocarbons were extremely minimal that we did see. So
thank you. The next one is, go ahead.
Yeah, just to add on to what Adam said, there's a differentiation between stormwater runoff and groundwater. The stormwater runoff does come from rooftops and parking garages that does pick up hydrocarbons. But when you have groundwater, the earth filters out a lot of all the natural hydrocarbons. All we had to deal with in this instance was basically the calcium and the magnesium ions. That was pretty much all we had to deal with. A little bit of silica, but no real issues with, other than silt and sediment, for which we have a couple of pre-filters, no real hydrocarbons in groundwater.
Thanks, Rahul. Next question is, have you had any concerns about redundancy with your water system?
Absolutely. Again, I'll reference our 2019 where we had issues in the county, and that was one of the main reasons to do a system like this. In my opinion, was redundancy. You know, with being in healthcare, I just can't shut this building down because we lost water. So we had to find a way to deal with stuff. And in the summertime, you know, we're making up somewhere around 100,000, 120,000 gallons a day just for our chillers. Now, 50,000 gallons a day for rainwater harvesting is not going to be enough. However, it does give us some redundancy if something would happen out in the community. The nice thing is I'd say September timeframe until most May. We really don't use city makeup at all. All of our city makeup is pretty much in the summertime. So it gives us some redundancy. It doesn't give us everything that I'd like, but it definitely gives us some. So.
Thank you. We have time for one or two more. So the next question is, you alluded to it a little bit during the last one, but have you thought about what would happen if the building actually lost water?
I would probably be in trouble. Yeah, we've actually had conversations, especially going back to 2019, about that. You know, at some point we would have to consider moving patients out of this building. You know, we're licensed for 450 beds, so moving 450 patients out would be quite a task. I know many hospitals have done it, especially, you know, from earthquakes to tornadoes and the areas that they may be, but yeah, it would not be a good day for a lot of us, and I'm sure a lot of us wouldn't sleep. So.
And then last question here, are you looking at any other sites to do similar projects on campus?
We are. We've actually investigated all of our sites. One site is a very good potential. There's another site that has potential, but not at the scale that we're doing it at the main campus. I do know of other sites in the state that are working towards a water harvesting system for cooling towers or other areas, but we have been investigating trying to see where we can save money. As everybody knows, the cost of everything is going up. So
if I can jump in there to answer that question, we have other systems operational in obviously in LA, as Adam mentioned. We've got another system operational that does about 5 million gallons a year in Schaumburg, Illinois. Ohio State has recently just ordered a system, and we're under manufacture of that system. So lots of groundwater, particularly in the Midwest, and the systems, with the help of Adam, we learned a lot operationally, not on the system design, but on the installation and the commissioning of the system. So with his help, things have become much more clearer on some of the pitfalls that we can run across.
That's great. Any last words before we go to the next presentation, Adam?
No, I appreciate, you guys invite me to this, and if anybody has any questions following up, I'm more than happy to answer and more than happy to have a discussion. I kind of love talking about this because it's been my baby for 5 years now, and trying to make sure that we are sustainable as best we can be. So I appreciate everybody.
Thank you very much. We appreciate it. That was a great presentation, great Q&A. So now we are going to hand it off to our next speaker, Chad Wilbanks. Chad?
Good afternoon, everybody. My name is Chad Wilbanks, Director of Training and Technology for the Water Tower. Officially been in the water industry for about 23 years now. All over the place, water, wastewater, stormwater, you name it. Do a lot of workforce development stuff with the Water Tower, but also get to check out innovative technologies and, look through just what they have to offer. And so today I'm going to talk about one of those very interesting technologies that I had the pleasure to not only participate in a pilot, but that also demo hands-on at our facility. Next slide. So a little bit about water tower programming. Anything from STEAM, STEM, next gen outreach to the local schools, workforce training I mentioned, networking, industry events, a lot of different research and development taking place right now, in our lab especially. And then just being that ecosystem, that houses and facilitates and cultivates, thinking and innovative processes. Next slide. So a little bit of a background. If you've ever had a leaky toilet, which doesn't necessarily mean it's spilling out into the floor, it could be leaking internally. It can waste up to a gallon of water every 30 seconds, which can add up to hundreds of dollars or more a day even, just depending on your rate structure from where your water's coming from. Not only that, but fixing a leak, even a simple leak, if you've got to utilize a plumber or somebody to come out to the house to do that, that can be very costly as well. So it's definitely a big issue. And the product we're going to talk about today is something that is a solution for that, as well as a few other features. Next slide. So product from AquaMizer. Essentially, AquaMizer Flush Solution is a sustainable product that was invented and designed to not only reduce the amount of water that a toilet actually uses per flush, but in doing so, it doesn't limit or take away the flush itself. So if you've ever been around any type of, especially like the DIY water saving things that you can do, filling up the water bottles or putting bags of marbles or whatever in the back of the tank, a lot of solutions out there will reduce the flow, but you also have a reduced flush, which, may have to flush more often or multiple times, and you're not really saving any water, right? So that is definitely where this solution is a lot different from that. So a little statistics here: on average, 1 out of every 20 toilets leak. It can be about a gallon per minute. And one of the great things about the AquaMizer solution and some of the findings I'll discuss in a few slides is um, the consumption can be reduced by up to 91%. So even if there is a leak, the actual consumption, it gets shut off. And then the overall amount of volume by your flushes is also reduced quite significantly. Um, One of the great things that this product allows for is it is a simple installation. So it's something that, even someone who is a novice just kind of, fix it here or there, watch a YouTube video. It would be something, very easy and simple for them to install. Next slide, please. All right. So what um, we did an on-site demonstration in our hands-on demo area at the water tower. And then we also took part of a pilot study. So this actually went from 2021 to 2023. The pilot project that was um, essentially installed at a multi-unit living facility in Lawrenceville, Georgia. It was a senior facility, and of course, we did the leak validation and other tests at our site. Next slide. All right, so for the pilot, excuse me. Um, this particular facility is a 48 room facility. Each of those rooms have their own toilet. So you can just look at it as, 48 toilets. So what we did kind of before we got started with this is we pulled historical data. How much water had this center been using historically over the past few years? And we compiled that with occupancy data as well. And we're able to extrapolate, the flows based on the occupancy because in a facility like this, it's much different than maybe a dorm or an apartment or a subdivision somewhere. These facilities can have turnover for various reasons, so we had to make sure that we had the occupancy data in there. Um, the install took right around 30 days to go through and complete each of the toilets with the AquaMizer unit. So AquaMizer unit was installed in each one of these toilets at this facility. And then we tracked the data for 18 months. So if you kind of look at this graph here, beginning in 2020, you can see off to the left the gallons, and then we've got it spread over time. Right at the point of the installation of the AquaMizer units, you can see a pretty significant decrease and then almost a bit of a plateau kind of beginning, but still maintaining that significantly lower water usage level than previously before. Next slide. So looking at their bills, you know, working with Gwinnett County, we were able to get the water consumption, but we were also able to get the billing information as well. And that kind of helped to really put it, we can talk about gallons and gallons all day long, but when we start talking about dollars, a lot of times that will definitely get folks' attention. So, looking at the left, the pretty much average monthly bill was lingering around close to $2,200 a month for this facility. And then after the installation, it was hovering around 890, $900. You can see, 153 gallons for consumption versus 59. So, you know, right at a 50% decrease in the amount of usage, which, for most things to um, qualify as, savings and stuff, a lot of times it has to at least be a 20 to 25%. That's considered, hey, you reduced it by 25%. This is really great. Well, this is, 50% and sometimes even more than that. So that was another thing that really kind of surprised me as we were going through this. Next slide. So the pilot we were kind of looking at, 3 areas for water and cost savings. We were looking at a lot of data from other things, um, you know, multi-unit facilities, whether it be a senior center or an apartment complex. Hotels are another great opportunity because, you have a lot of rooms. Every one of those rooms has a toilet. So there's a lot of things here that kind of makes it impactful for that multi-unit area. Looking at a report from Marriott, essentially 10% of all the toilets were leaking at 3 gallons per hour. So that turns out to be quite a significant amount of money over time. And not only do you have to worry about water loss, so the toilet is leaking through the flapper or in another part of the tank, you also have to worry about a toilet getting stopped up. Because in these situations with, multiple units together, one person's accident or, mistake or whatever could essentially affect a lot of other folks. So that could lead to, a significant amount of money in insurance claims and things of that nature with just one catastrophic failure. Next slide. So for our demo, we wanted to make sure we did as close to a side-by-side comparison as possible in a controlled environment. So we set up an area outside the demo site that simulated a home with, all the way down to the floors and the flange and the pipe coming out of the toilet, everything, although it was not connected up to the sewer system because we were just running potable water through it. We set it up side by side as if it would be installed in a home or in a facility somewhere. Purchased 2 identical toilets, just your basic toilet from Home Depot. Brand new toilets at the time, still probably selling the same toilet today. 1.28 gallon per flush, high efficiency. When setting them up, we left one of the toilets completely as it came from Home Depot out of the box. And then the other toilet, we removed the contents of the tank and installed the AquaMizer unit. Then we established what we were looking for in regards to our controlled parameters, which I'll talk about on the next slide. So we actually wanted to see gallons per flush. You know, wanted to test the ability to really see if that Glacier Bay toilet is 1.28 gallons per flush and really see if, AquaMizer reduces further than that. One of the most common failures for various different reasons is the flapper inside the tank, either being stuck or coming apart or whatever the case may be. So we simulated a flapper fill. Also want to simulate a clog. Clog is another issue that happens that can cause not only a significant amount of water to be wasted, but it could lead to costly repairs. And then a tank leak or a tank failure. So the tank bolts begin to rust. It happens in every single toilet over a period of time after a while. Sometimes tanks can crack or can, be put under stress and leak. So we simulated that as well and wanted to see just how each of the toilets responded in this controlled experiment. Next slide. So both of them were connected to their own standard supply line, just like you would have in a home. There was an independent flow meter attached to each of them. And then we began recording the data. So looking at the actual gallons per flush, the Glacier Bay came out to be 1.32 gallons and the AquaMizer was 0.68. With the simulated flapper failure, this was a 5-minute test. In 5 minutes, the flapper failure on the stock toilet was 6.6 gallons, 0.75 gallons, so less than a gallon, with the AquaMizer solution. When we simulated the clog, again, we did another 5-minute test with this. We had 7.4 gallons of water that essentially spilled out of the toilet, right? And the bowl began to overflow. With the AquaMizer solution, it was only 0.68 gallons that was consumed or used, and there was no overflow. So not only did there not be a significant increase in the water consumption, there was no overflow, which to me is huge, because worst thing you want to do is have to come home to a flooded house and start repairing carpet and replacing stuff and all that. So, and then the tank failure. So we simulated a crack, 6.8 gallons in that 5-minute test, and water was leaking from the tank onto the subfloor that we created. With the AquaMizer unit, it was 0.56 gallons, and there was no leak. There was nothing that made its way down to the subfloor. Next slide. So some of the data that we were able to pull from this, the average low flow is between 1.3 and 1.5 gallons of water per flush. On the standard toilet in our demonstration, we found those numbers to be right in line with what the standard is. The toilet with the AquaMizer upgrade used significantly less, between 0.6 and 0.75 gallons per flush, reducing at least 50% of the amount of water per flush. With that standard low flow, if the flapper stick broken, as I've mentioned before, looking at the amount of water that can come out spread over an entire day's time, it could be up to 4,300 gallons of water per day per toilet. Essentially the same thing with a clog, using that same flow rate that was established in our experiment. You're looking at, around 4,300 gallons that could essentially enter the home even, in one of the worst circumstances, causing significant amount of damage, insurance claims, a lot of stuff that nobody wants to deal with. The AquaMizer unit stops flowing the water in the event of a clog or issue with the flapper. The failsafe essentially mitigates damage that can be caused by flooding, resulting in no water leaving the toilet and flooding the home. So it was really neat to actually see that. Next slide. So what we discovered is, the information we received about the unit was correct. And actually, I think we may have even, uncovered a few other things that were very beneficial for this product. The unit not only reduces the water usage by at least 50%, but it also provides a viable solution to mitigate property damage and loss that can occur with any type of toilet issue. The standard low flow toilets that are brand new that you can go buy today, they are significantly less than toilets that we purchased 20 years ago, but having this solution takes it a step even further. Looking at the data on the graph from Brookdale, there was a huge decline, not only in their bill, but their consumption. And all of that was correlated with the occupancy at the time. So, I should have put that slide in, and I apologize for not doing that. But with that direct correlation, it proves that it's not just, okay, well, maybe they had, 40 units filled and then they had 20 units filled, because obviously there'd be less consumption with less people. But we took all that in consideration when coming up with our data. So this is one of those really cool times where you hear about a product, you put it to the test, and you actually find out that it does what everybody's saying that the product does. So it was a really neat opportunity. And again, at the water tower, we love any chance that we can, test out and validate things, and then begin to sing their praises if they do good. And then if they don't do good, we can just equally decide to not talk about it. So, but that's it for this. If you got any questions, definitely feel free to put it in the chat there.
Thanks, Chad. We do have some questions in the chat. So the first one is, it looks like there was a bit of decrease in water use even before the AquaMizer installation. Do you have any idea what that might be attributed to? Great to see it plateau at a lower level after installation.
We do know that early on they had some issues with their water meter and they even had a water leak. And so right after one of the first peaks, there was a pretty good drop because they had some of their external issues corrected. Um, but then once we performed the installation, you could definitely see, with both the water bills and the consumption reports from the county, that there was a significant decrease. I even had the individual with the county that was getting me the information for this. Every time that I would talk to them and say, hey, can I get another report? They're like, wow, I don't know what y'all are doing out there, but this place is like hardly using water at all now. So they were pretty excited to see that, some changes were being made in that regard.
Thank you. The next question is, would this be adaptive to older toilets as a retrofit possibility with older low-income housing?
Absolutely. That is one of the, best applications for it, in my opinion, because this unit is not specific to just a certain brand or type of toilet. Um, with toilets, regardless to how simple or how complex they are, they're either considered 2 inch or 3 inch, with what's leaving the tank and entering into the bowl. And the Aquamizer unit has sizes that cover both of those. So it will fit essentially in any toilet that could be installed today. I couldn't think of a toilet that would be out there that this would not be a retrofit for, from the oldest all the way up to the ones that we purchased at Home Depot.
The next question is talking about the study. So why look at a senior living facility instead of a traditional home?
Well, one of the things we wanted to do is we wanted to test this out in a place where there could be a significant difference made, where you could truly see it. Um, so, speaking with Marriott, speaking with Brookdale and other places, there is when you attach the dollar side to it, or you attach the potential for, that loss mitigation to it, um, their eyes open, their ears open, and they were very accepting of coming in and doing a pilot, doing a study. When you're looking at single family homes, you have to try, just for the purposes of a study, you want to try and have your area in a small area where you can minimize the amount of variables possible, so that you can make sure you're getting accurate data out of the pilot. And with that, you've got to go out, try and meet with homeowners associations and, get everybody to agree to have this installed, and then share information and share data. And it's just a little bit more challenging. I mean, this product is just as beneficial in your home as it is for a multi-unit facility, but the savings and the significance of it was more appealing to, you know, um, senior living facilities, hotels, apartment complexes, than homeowners that, for the most part, have, two toilets in the home. So looking at, the savings and the data and all the other things, it was a lot easier to control the variables doing it like this than it would have been to try and cover, multiple homes all over Gwinnett County.
Thank you. Next question is, when conducting the demo at TWT, did anything pose a significant barrier to performing the testing?
So, doing it at the water tower, it was, and that was the other thing, kind of back to the previous question. I knew that we could simulate what it would be like in a home and control that data. And so the multi-unit thing, it just made even more sense to do the pilot there. Really and truly, the barriers being outside and trying to make sure that, everything was done exactly the same so that there wasn't any pros given to one over the other. Coming in completely with the same piping, the same flow rates, the same meters, all of that stuff, simulating the subfloor with the flange and actually bolting the toilets down to it and all that. That was a huge consideration. So the only thing I could think of is, the ability to do it continuously for long periods of time and being able to watch it in that regard. But I think for the most part it was pretty easy.
Thank you. And then the last question is, what were some overall lessons learned that came from the pilot study?
So for me, and I try to learn every single day of my life, but every time we are involved in a pilot or a demo, I always learn so much. And for me, I feel like knowing the low flow toilet's a brand new toilet, it really surprised me that the AquaMizer unit was able to reduce that significantly. So if you take and some of the data we have from Brookdale, with some of those toilets, the 3 and 4 and 5 gallons per flush sometimes. I mean, it was just it blew my mind just how much water with a toilet in some cases was only 5 years old, how much water was being used by the specific toilet, versus the brand new toilet, and then how the AquaMizer unit was able to decrease it so much. And then the other thing was just the simplicity of it. So, this is not like a device with hoses and wires and cables and, requiring power, it is essentially, if you take the guts of the toilet out, like you might have to replace it periodically, whatever, these are the same components. They've just been designed differently, and they've been designed to all work together with a couple of different little fail safes inside to provide security. So it really surprised me that it actually worked, because when I first looked at it, I'm like, this looks the same as the repair kit I can buy at Home Depot. So what makes this special? Well, I was able to find out what made it special, doing the study. So that was really nice too.
Thanks very much, Chad. And thank you to Adam as well, both of our speakers, for excellent presentations today. The solutions that you saw here today are actually part of the Water Tower's Building Scale Technology program, so we're excited to include them in that. If you're interested in learning more about these technologies or the Water Tower in general, please contact us or check out our website or look at our social media at the H2O Tower. We did have a question, a general housekeeping question about certificates, and we will be providing PDH, 1 PDH hour certificates to all the participants on the call today. So you will be receiving those next week. And with that, this concludes today's virtual Lunch and Learn. We hope you had a great time and learned a lot. Hope you have a wonderful weekend, and thanks again for joining us. We appreciate it.